Today's lesson is about maximum and minimum values. These maximum and minimum values we're studying are on functions. Some of the most important applications of differential calculus are optimization problems. We are required to find the optimal or best way of doing something. The figure shows the graph of a function f with absolute maximum at D and absolute minimum at A. Note that the point D, f of D is the highest point on the graph, and A, f of A is the lowest point on the graph, on the interval that's shown. A function f has an absolute maximum, or some will call it a global maximum, at C if and only if f of C is greater than or equal to f of x for all x in some domain D. The number f of C is called the maximum value of f on D. Similarly, f has an absolute minimum or global minimum at C if f of C is less than or equal to f of x for all x in D. And the number C is called the minimum value of f on D. The maximum and minimum values of f are called the extreme values of f. In this example, we're going to find the absolute max and min values for f on the given interval. The function we're studying is sine of x plus cosine of x. The interval is from 0 to pi over 3 inclusive. Well, if I'm looking for maxes or mins, I think back to that diagram we just had. Notice that maxes and mins occur at points of horizontal tangency. So that happens when the first derivative is 0. So basically I need to find where the first derivative is 0 or where the function is undefined, and that's where my maxes and mins are going to occur. Let's go back to that slide. So my first derivative, if I take the derivative of f, f prime would equal, let's see, the derivative of sine we know is cosine, and the derivative of cosine is negative sine, so there's my first derivative. I need to know where that equals 0. So I'm going to go ahead and set that equal to 0. I think I'll add sine to both sides. And I can solve this by inspection. I know that cosine of x equals sine of x when x is 45 degrees or pi over 4. That gives me a few critical points to look at for maxes or mins. Those critical points could happen on the endpoints of the interval. They could happen where the first derivative is 0, or they could happen where the derivative is undefined. Or excuse me, where the function is undefined. This function is defined on that whole interval. And so really we only need to look at x equals 0, x equals pi over 4, and x equals pi over 3. Again, we need to check the endpoints for our highest and lowest value, endpoints of the interval. And we need to check anywhere where the function is, first derivative is 0 or undefined. So if we take 0 and plug it into the original function, we find that the highest, or the value there is 1. We plug pi over 4 into f of x, we find root 2. If we plug pi over 3 into the function f of x, we find root 3 plus 1 all divided by 2. We're looking for the highest and lowest values here. The highest value is root 2 and the lowest value is 1. So we would say that our maximum value is at pi over 4 and that it is root 2. We would say our minimum value is at 0 and it is 1. On the next slide, we'll have one for you to try. Find the absolute maximum and minimum values of f on the given interval. The function is x to the 4th minus 2x squared plus 3, and the interval is negative 2 to 3 inclusive. Now notice, this is a problem we should be able to do without our calculators. Now you might want to plug in negative 2 or 3 or whatever you get to do some calculation, that kind of calculation. But we don't want to do any graphing here. We should be able to do this without a graphing calculator. So go ahead and pause the video right here, give this a try, and when you're ready to check your answer with mine, press play. Okay, let's see how you did. First thing you're going to do is take the derivative of the function. So f prime would equal 4x to the third minus 4x We should also note that this function is continuous on the interval from -2 to 3. There's not going to be any breaks or gaps or jumps. Let's go ahead and see if we can figure out when this function equals 0. If we factor out a 4x, we have 4x times the quantity x squared minus 1. If we factor the difference of squares, we get 4x times the quantity x plus 1 times the quantity x minus 1. By inspection, we see that this thing equals 0 at 0, -1, and 1, which are all on the interval from -2 to 3. So we have 5 critical points to check. We have the endpoints -2 and +3, and we have the zeros -1, 0, and 1. Now it's just a matter of plugging these values into f, or substituting, evaluating them in f, and seeing what values we get. If we insert -2, we get 11. -1 gives us 2. 0 gives us 3. 1 gives us 2. And 3 gives us 66. So we have a definite maximum value at 3 of 66. We have the minimum value occurs twice, and if you remember that slide that talked about minimums, it said that f of c had to be less than or equal to all other values that you could possibly plug in. Well, -1 and 1 both give the value 2, so they are the lowest value of anything on the function except for the other. So that's the less than or equal to part of the definition. So our final answer would be we have a maximum at 3. The maximum is 66. And we have a minimum happens in 2 places, at 1 and -1, and that minimum is 2. That's our learning target for this lesson. I'll see you in class.